Hello, this is Tim Smith, the Academic Support Coordinator for St. John's River State College, St. Augustine campus. This lesson on absolute value functions is designed as a study aid and supplement to the math tutoring services offered at St. John's River State College. In this video, we will review absolute value expressions and discuss absolute value functions, graphing absolute value functions as piecewise functions, solving absolute value equations, and solving absolute value inequalities. The absolute value of a real number a is defined as the distance from 0 to a on a number line. The absolute value of a number is notated by two vertical bars. The absolute value of a equals a. The absolute value of negative a equals a. The absolute value function takes the form f of x is equal to the absolute value of x. The domain of the absolute value function is on the interval negative infinity to positive infinity. The range of the absolute value function is on the interval 0 to infinity. The x and y intercepts of the absolute value function occurs at the origin 0, 0. The absolute value function is symmetric across the y-axis and as such is an even function. The absolute value function may be graphed by first taking a set of ordered pairs. When x equals 0, the absolute value of 0 equals 0. The absolute value of 1 is 1. The absolute value of negative 1 is 1. The absolute value of 2 is 2. And the absolute value of negative 2 is 2. The domain of the function is on the interval from negative infinity to positive infinity, and the range is from 0 to infinity. The graph is subsequently shaped like a V with the base at the origin. Transformations may be taken from the base function by shifting the graph. The absolute value of x plus 1 shifts the graph up by 1 and changes the range from 1 to infinity. Subtracting would shift the graph down. Adding 1 to the inside of the absolute value function shifts the graph to the left. Here the range is from 0 to infinity. Conversely, subtracting in this case shifts the graph to the right. Multiplying the absolute value function, as in 2 times the absolute value of x, vertically stretches the graph by a factor of 2, and multiplying it by a number between 0 and 1 would vertically compress the graph. This action does not change the range. F of x is equal to negative the absolute value of x reflects the graph across the x-axis. The range of this function is from negative infinity to 0. For many applications, it is helpful to think of the absolute value function in terms of the piecewise function f of x is equal to x for all x greater than or equal to 0, and negative x for x less than 0. When solving absolute value equations, both positive and negative answers must be determined. If the absolute value of x equals a, then either x equals a or x equals negative a. For example, if the absolute value of x equals 5, then x equals 5 or x equals negative 5. The absolute value function also dictates that the result will never be a negative number. Therefore, the absolute value of x equals negative 10 results in the null set. In the next example, the absolute value of negative 3x plus 20 equals 35. Since the absolute value is isolated on the left side of the equation, we can resolve the absolute value in the first step. Negative 3x plus 20 equals 35, or negative 3x plus 20 equals negative 35. On the first equation, we subtract 20 from both sides to get negative 3x equals 15, divide by negative 3 to get x equal to negative 5. On the other equation, subtract 20 to get negative 3x equals negative 55, then divide by negative 3 to get x equals 55 over 3. In another example, the absolute value of 5x plus 8 minus 3 divided by 7 equals 6. The absolute value function is not isolated, so we start by multiplying both sides by 7 to get the absolute value of 5x plus 8 minus 3 equals 42. Then we add 3 to get the absolute value of 5x plus 8 equals 45. Now we can resolve the absolute value to get 5x plus 8 equals 45 and 5x plus 8 equals negative 45. In the first equation, subtract 8 to get 5x equals 37, Then divide by 5 to get a final answer, x equals 37 over 5. On the other equation, subtract 8 to get 5x equals negative 53. Then divide by 5 to get x equals negative 53 over 5. Just as with equations, when solving absolute value inequalities, both positive and negative answers must be determined. If the absolute value of x is greater than or equal to a, then either x is greater than or equal to a, or x is less than or equal to negative a. Note that when taking the negative half of the absolute value solution, switch the inequality sign. For example, if the absolute value of x is greater than 5, then either x is greater than 5 or x is less than negative 5. This can be expressed on a number line as follows. In another example, we start with the absolute value of x is less than or equal to 3. This leads to the compound inequality, negative 3 is less than or equal to x is less than or equal to 3. This can also be depicted on a number line. Solve the following absolute value inequalities. The absolute value of 3x minus 7 over 2 is less than 5. The absolute value is not yet isolated, so we start by multiplying both sides by 2 to get the absolute value of 3x minus 7 is less than 10. Resolve the absolute value to get the compound inequality, negative 10 is less than 3x minus 7 is less than 10. We add 7 to get negative 3 is less than 3x is less than 17. Divide by 3 to get negative 1 is less than x is less than 17 over 3. In another example, the absolute value of 3x over 2 plus 8 is greater than 6. First, we subtract the 8 to get the absolute value of 3x over 2 is greater than negative 2. Here we remember that an absolute value term will never result in a negative number. The inequality sign, though, is greater than, so this absolute value is equal to the absolute value of 3x over 2 is greater than or equal to 0. We resolve the absolute value to get 3x over 2 is greater than or equal to 0, and 3x over 2 is less than 0. We can stop here because we realize that we are describing a situation where x is a set of all real numbers. If you have further questions on this or any other math topic, or wish in-person tutoring, please consult the Academic Support Coordinator on your respective campus. Thank you, and good luck with your studies.